Hi guys, welcome back. This is part 3 of our automatic temperature control project with Flowcode. In part 1 we designed the circuit diagram. In part 2 we started with the flow chart of this project, and in this third part we're gonna finish up the code. Let us run the project and see where we left off in part 2. Automatic temp reference temperature. You can enter your reference temperature. Let's say 45, enter. So the problem, you can only access this reference temperature menu on startup. If you want to change the reference temperature while your device is running, we're gonna create some new code. You can press and hold the star key, then it's gonna bring up this setup menu again. Okay, so in the while one loop, this execute continuously. We're gonna read the keypad, get number, and if it was the star key that was pressed, we're gonna say if key equals to 10, because the star key is gonna return the numerical value of 10. We're gonna wait for 3 seconds to check again. We're gonna read the keypad again, get number, and if the key is still pressed, then we're gonna call the setup temp reference macro again. You can see the advantage of using macro, so we don't have to write that code again. We can just call it setup temp ref. That's run. Now set it to 13. Okay, the current reference temperature is 13. If I can press and hold for 3 seconds, then it's gonna bring up that menu again. Okay, I'm gonna set it this time to 46. Okay. Now once we have set up our reference temperature, we need to store it into the peak EEPROM so that whenever we start up our device, we don't have to enter again this same reference temperature. We can only change it if you want a new reference temperature. So I'm gonna need a EEPROM component. This is gonna enable us to write the internal EEPROM. We can also use an external EEPROM, but I think for this application we only need a few data, so internal EEPROM should be more than enough for application. Because this is the initial values that will be populated to the EEPROM. The supported format are in decimal from 0 to 255, the hexadecimal from 0 to FF. We can also enter the value in ASCII or a string. So we don't want to have initial values, so we're gonna delete these initial values. Before we call the setup macro, we're gonna start reading first from our EEPROM to find out if you've got some stored setting value. So we're gonna check read EEPROM. We've got only 2 functions. You can either read or write. The read is very simple. You just have to specify the address that you're gonna read from, and you're gonna return the data. We're gonna return and store it into a variable. We're gonna create a new variable. We're gonna name it EEPROM value. It's gonna be a byte variable. Then we're gonna check if we've got something. We're gonna initialize our reference temperature with this value from the EEPROM. The reference temperature equals to EEPROM value. Then we're gonna check if this reference temperature is greater than 0. and less than 100. Let us invert our if condition. Gonna swap it. So if the reference temperature is greater than 0 and is less than 100, it basically means that we've got a reference temperature in EEPROM. So we're gonna go straight to our main loop and start reading the temperature and compare it. We're not gonna prompt the user to enter a new reference temperature. But if the value equals to 0, then we're gonna prompt the user to set up a new reference temperature. And in the setup ref macro, once we have set up this new reference temperature, then we'll have to store it into the EEPROM again. So basically, after we have set up our reference temperature, we're gonna display it to the LCD, then we're gonna store it into the EEPROM. EEPROM write the address, it's gonna be 0. You must always write to the same address that you're gonna read from, and the value that we're gonna write the reference temperature. And that's all, guys. Let us run our project. Enter ref because there is nothing in the EEPROM. If you click to view console, you can see everything is FF because there is nothing stored in the first byte. There is nothing. We're gonna enter a new reference temperature, 27, enter, and you can see that value is stored in EEPROM. 27 is 1B in hexadecimal. If I can stop the simulation and run it again, you can see it goes straight into the main code. It does not prompt me to enter a new reference temperature because it's gonna read the reference temperature from EEPROM. Okay, save. Let us compile the project. The compilation was successful. Let us simulate in Proteus. Before you simulate an EEPROM with Proteus, you must always reset first the persistent model data. It said the persistent model data is model data like EEPROM that ISIS maintains between simulations. This basically is gonna clear all the previous values stored in EEPROM. Click yes. Run. Automatic temperature control. We're gonna set the reference temperature to 20. You can see the current temperature is higher than the reference temperature. That's why the fan is rotating to cool off the area. If the temperature can decrease below the reference temperature, you're gonna see the fan is gonna be off and the heater is gonna be switched on to warm up the area. Let us press and hold the star key again to set up a new reference temperature. We're gonna set the new reference temperature to 27. Press the H key to continue. You can see now our new reference temperature is 27. We're gonna restart the simulation. Stop, start again. You can see the reference temperature was read from the EEPROM. It did not prompt us to enter a reference temperature. And that's all, guys, for this tutorial. There are some other features that can be improved on this project if you intend to build it. This just demonstrates the basic features that can be built upon to design your own project. Here are some few things that you might consider. Instead of using only one analog sensor, you can use more than one sensors, maybe two, And instead of comparing the reference temperature to a single temperature, you can compare it to the average temperature from the sensors. Instead also of having a fixed reference temperature, you can also use a range to avoid oscillation. Instead of comparing to a fixed reference temperature, for example, 27, you can compare between a range of a minimum to a maximum, or add an offset value to your reference temperature and only control the relays once the red temperature is outside this range to avoid oscillation, because in theory this project can switch on and off a relay even if the difference in temperature is less than 1 degree. So if our current temperature, let's say, is 27.1, in theory, it means the current temperature is higher than the reference temperature, then it's gonna switch on the fan. And if this temperature can just decrease to 26.8 or 26.9, in theory, it's gonna switch on the heater again. The project is not gonna be stable. The relays can oscillate. So instead of comparing to a fixed reference temperature, it's better to use a range of a minimum to a maximum, or add an offset value to the reference temperature and only control the relays once the red temperature is outside this range to avoid oscillation. You can also add a humidity sensor to your project. You can also control the speed of the motor. And there are some other more features that you can consider. But to make this project simple and short, we're just gonna limit ourselves to this. Thank you guys for watching this tutorial. Please leave a comment. Let us hear from you what you could improve on this project. And I will see you guys in the next tutorial. Thank you.